So here are a couple of words about me. I'm working on Rime, which is a platform that you can actually today use in order to follow along the workshop. This is a platform which allows you to build more scalable and consistent workshops and corporate trainings by using virtualization in the browser. And I'm also quite active in the open source community. So I'm a former member of the Angular mobile team. I also, together with John Papo, Igor Minar, and Ward Bell, worked on the Angular style guide, which is now on Angular.io. I'm working on Angular Seeds, Colorizer. Colorizer is a tool for static analysis, which you might be already using in Angular CLI, and a couple of other projects, which are related to the Angular compiler mostly. So the workshop today, I want to focus specifically on runtime performance. Previously, I was building a lot of content related to making our bundle smaller. But as you saw yesterday on the keynote, the Angular team is working in the exact same direction. So we have Ivy, and Ivy can allow us to build a hello world, which is only 2.7K. And we have amazing tooling underneath in the Angular CLI, which allows us to tree-shake our application, apply different dead code elimination techniques, and so on and so forth. However, regarding runtime performance, everything is in our own hands. So we need to take care of this. So there are a couple of techniques that we're going to take a look at. I tried to make them Angular-specific, but also to allow you to see where they're inspired from. So most of them are inspired from functional programming, and you can apply them not only in Angular, but in other technologies as well. If you want to follow along with me, you can join on this URL right here, rime.com/go/ngperf. If you're watching the live stream, you should be able to join on this URL as well. After registration, you should get a virtual machine, which has the exact same setup as like everyone else. It has the project pre-installed. It has Node modules pre-installed, so you don't have to waste time in this. It has VS Code and a few other tools which I thought it might be appropriate. After you register, you're going to see a screen similar to this one here. So your virtual machine is going to be on the left. You can control it, and you can follow along with me there. And on the right, usually there is a video of me showing something, or of the guide showing something, either a video or just their virtual machine performing. But however, in this case, you're going to see my screen here on the wall. So you can just collapse the right side. If you're following the live stream, you can watch the video on YouTube and follow along with me in your virtual machine. Right, so we're going to take a very simplified business application today, and we're going to discover all the performance issues that it has, and we're going to go step by step into optimizing it and making it faster. Let's take a look at the business app. So you can open if you're following along, you can go to Projects, Optimizing an Angular App, and you can run ng-serve there. This is an Angular CLI application. So until this loads, we can just briefly take a look at the code base. So as in any Angular application, Angular CLI application, we have a main file. In the main file, we are bootstrapping the app with the app module. In the app module, we have the bootstrap component, app component, which internally has a template. And in this template, we're creating two instances of the employee list component. Also, we're holding some state inside of the app component. We're holding two arrays of items of type employee data. That's pretty much what is interesting about this component. We can take a look at the employee list component right after that. But before going into the employee list component, let's take a look at the application. So that's it. We just have two lists of items. We have a list for a sales department and a list for the R&D department in our organization. And for each individual list item, we have a name and a numeric value. This numeric value goes through some heavy computation. So it can go through whatever business-specific computation you have in your application, like standard deviation or whatever makes sense for you. And also, we can add new employees. For instance, here is Jason. We can remove employees, and so on and so forth. So statically, the application structure looks as follows. we have our app here, and it is built with two components, with the app component and with the employee list component. The app component wraps the entire application, and it also holds some additional pieces of logic. The employee list component wraps the individual department in our organization. So it can wrap the sales department or the R&D department. And the interesting thing, which we already mentioned, was that our app component holds the state. So it is the container component. And the employee list component just visualizes it and does some aggregation regarding the numeric value for the employee data. So that's it. And yeah, I used a very simplified calculation. I just mocked a business calculation in order to make sure that we are all familiar with the computation. And in the same time, it is implemented in a very inefficient manner. So we can stress even further on the optimizations that we're going to perform. So Fibonacci is actually not too far from real world, because it has very important characteristics that most calculations that we would want to apply in our apps have. We're going to stop on this in a little bit later. So yeah, that was the app. It looks quite simple. But let's add a little bit more data. So we can just switch to the branch on push and optimized. After the browser reloads, we're going to see that we have a few more items. In fact, we have 140 items, so not that many. And if we try to add a new employee, yeah, I'm typing right now. Still typing. I'll stop. All right. Yeah, that was it. So it's pretty slow. And this is with 140 items. There are not thousands. Yeah, it is very slow, obviously. And it is interesting to see why it is that slow. So we can use Chrome DevTools. We can just open the Performance tab here. I'll do, and just start a recording. Let me rephrase, because it's going to take less time than pressing backspace. So once we start recording, I will type several characters. Chrome DevTools here is going to make a recording of which functions are invoked, how often do they get invoked, and how long does it take them to their execution to complete. After we press stop, Google Chrome is going to just aggregate this data and show us what's going on. So we can see that we spent a lot of time in scripting. When we take a look at the bottom-up tab, we're obviously going to see that our Fibonacci implementation gets invoked far too often. So let's see what is actually going on and why it gets invoked that often. Each time when the user presses a key on the keyboard, we're going to invoke multiple times the change detection for, first, the app component, which is the root component in our app. Right after that, we're going to perform the first traversal. So we're going to go to the employee list component for the sales department. We're going to compute the numeric value for the first employee, for the second employee, and so on and so forth for all the employees in the list. We're going to do the exact same thing for the other department. So we're just typing something into the text box, but the change detection gets invoked for each individual component, although there are obviously no changes. So what we would want to do is to invoke the change detection for each individual employee in the list only when we get a new list, right? It makes sense, because otherwise we have already computed this data, so we don't want to recompute it. But if we get a new list of employees, we would want to go through each individual employee and recompute this data again. So we can use onPush. Yeah, that's a very popular optimization practice that we can apply in our applications. And the onPush change detection strategy is going to help us in a way that it is going to trigger the change detection in component when this component receives a new input. So when the component receives a new input, for instance, our employee list component receives a new reference to an array of employee data objects, we're going to trigger the change detection there. This means that passing a new reference is going to trigger the change detection. So Angular internally is comparing the data structure of the current input and the previous input by using a reference check, which is very fast. It has constant complexity, but it may require us to create a new reference of the array, right? So this might not be extremely convenient for us. This means that we may need to copy the entire array in order to make sure that Angular knows that we have added a new employee. So this is not very convenient because at first it's very slow. We need to iterate over the initial list in order to copy all the items from it into the new one. And right after that, we're going to allocate a lot of additional memory, which we really don't have to. So we can use Immutablejs for the purpose. How many of you have actually used Immutablejs? All right, a couple of you. Well, this is a technology by Facebook, which implements a lot of immutable data structures in a smarter way. So internally, they are using persistent data structures with partial persistence. And this has two important characteristics. First, we're going to get a new reference every time when we intend to apply a mutation on top of a given instance of a data structure. So we are adding a new list to our immutable list, and we're going to get a new list. So the initial list is going to be unchanged. And also, we need to copy the entire data structure. We don't need to copy the entire data structure because internally Immutablejs is reusing everything it can from the original list. Right, so let's do some refactoring, and right after that, I'm going to show the bench press results. So first, what we need to do is import the immutable list from immutable. And we need to change our employee data to use immutable lists. We can see that we're getting an error here. That's because list and sales and R&D here needs to be converted to immutable lists. Also, the add and the remove method needs to accept immutable lists now. So we can just change this. And that's it. So there is something important to notice here. I mentioned that when we mutate an immutable list, we're going to get a new list. And here, we're not doing anything with the new reference. So we can just return it for now. All right? And we need to assign it to the already existing reference for the corresponding list. So here, we need to assign it to the sales list again, and here R&D list. All right. So now there is also one more change that we need to do. So when we go to the employee list component, we need to change its input data to be of the appropriate type, immutable list. And since we're using the length property of the array, we need to change it to size, because that's what the immutable list uses. All right, and the final thing is just to change the change detection strategy of this component. So we are using change detection strategy dot onPush. Cool. Let's see whether everything works. Everything seems fine. Now, yeah, well, we should have a very fast app, right? I'm typing. Yeah. It's not too fast, isn't it? So it was not even able to accept my first character, I guess. And when we remove items, it is still very slow. So onPush, I guess it is not the only optimization that we need to apply, right? I didn't think initially that I have any performance improvement, so I did some performance benchmarks with Angular bench press. And here is what I found. It is at least twice faster, but it is still very slow. So we need to put a little bit more effort into this and see what is actually going on. In order to do this, let's just inspect it. So let's go back to our list component and add one log statement. So I'm just adding the log statement into the calculate method, which is invoked for each individual employee in the list, and just logging, calculating, and the name of the department. So when I start typing something, we can see that the sales department is going crazy. We're recomputing the numeric values for each individual employee in the list when we are typing. And the understanding of the onPush change detection is that we're going to trigger the change detection when our component gets new inputs, right? This seems that is not exactly the case, because we're not creating new lists of items, so we're not changing any references. Well, I was very interested in what is going on, so I took a look at the integration test of Angular core, and I found out that Angular is also going to invoke the change detection of a component with on-push change detection strategy when an event inside of this component gets triggered. So this wasn't something too obvious, and I had to do some refactoring in order to fix it. So here is the refactoring that we're going to do now. We're going to decompose our employee list components to the name input component and to the list component. So our name input component is going to encapsulate all the events which are happening while we're typing something, like the name of the new employee. And the list component is going to use on-push change detection strategy. It is going to render the individual items and compute their numeric values. So this way, we're going to encapsulate all the events. They're going to be isolated in the name input component, because the name input component is a sibling component of the list component. So the list component is going to be just not going to need to recompute anything. So let's do this. And after that, we're going to explore what is actually going on in terms of change detection invocation. So first, if you're following along in your virtual machine, you can go to src app employee list. And here we want to use Angular CLI to generate a new component. So ng-gc, Angular generate component, name input. Keep in mind that we're adding a declaration of this component in the employee list module. So we want to do the exact same thing for the list component. So we have our two new components, and we need to move some logic to them. So our list components needs to handle key down events. So our name component, excuse me, name input component. So we can just move this logic to this component. We can remove the onInit lifecycle hook because we don't need it. And here, Colorizer complains that we're not following the convention in our application, so we need to change the prefix of this component selector with SD. And we're also missing the at output, so we need to copy this output as well. You need to import the event emitter and make sure that you import the correct event emitter from Angular core, because the first suggestion is from Protractor. All right, so it seems that we're good with the name input component. Let's go to the employee list component now and copy the template. Just move it to the name input components template. Right? And we need to do the exact same thing for the list component. So we're copying the material design list to list component. And we need to copy some logic as well. So we need to copy the calculate method, and we will need to copy the remove output as well. And finally, Fibonacci. And we no longer need the calculate method. And now we need to add these components in the employee list components template. So here we need to add the name input component, which throws one output at. And we need to handle it just by emitting the value that it throws. We need to do the same with the list component. However, here the output is remove. And we have the data input. So let's see whether this works. All right, the SD list is missing here. Oh, it's right here. Oh yeah, I didn't add the input of the list component. So it is right here as well. All right. So the layout will be a little bit broken because we didn't move styles. We're going to do this as well. Now let's move the styles from the material design form to the name input component. And the rest of the styles, we can move to the list component. And this should look a little bit better after we refresh. And there is one final optimization that we need to perform. We haven't actually changed the change detection of the list components to use on push. All right, we can save this. And now we can start typing. Yeah, it's so much faster, right? Yeah. So in fact, that's how much faster it is. And here is what is going on. Every time when we start typing something, we're triggering the change detection strategy in the app component. After that, we're going to the employee list component, and everything stops here. This happens because the name input component is inside of the employee list component, so we're triggering the change detection in the employee list component as well. Eventually, if we remove the on-push change detection strategy from the employee list component, we may invoke the change detections also in the employee list component for the R&D department, but this will happen only if we want to do that. I mean, we don't have to. But also, the computations happening in the employee list component are very light, so if we invoke the change detection there, it's not going to be a big deal. Yeah, so we saw how fast it is. But let's see how quickly we are adding new items. So my machine is quite fast, actually. But let's add the log statements to see what is going on. There is still some delay, which is about 100 milliseconds eventually. So we can add a log statement. We just says calculating, and that's it. So we're adding, now when we are typing, nothing happens because of the optimization that we just did. But when we press Enter now, we are calculating a lot of values. In fact, there are exactly 71. We're calculating the value for the new employee and all the other employees from the list. Although we have already calculated their values, so it doesn't really make sense to recompute them, right? But that's how the Angular change detection works. It is just going to take a look at, so first, let's go to the diagram. We're going to add a new element. We're going to trigger a change detection in the app component. The change detection is going to be triggered in the employee list component. After that, in the list component, because we have gotten a new reference, right? We have added a new element, so we have created a new immutable list, which we are passing as an input to the list component. So the list component's change detection gets triggered because it has received a new reference for its list, for its input. And this is going to recompute the numeric values for each individual employee in the list, because we're going to just recompute all the calculate calls in the ng-for in the template. So this is not too practical. We're recomputing everything every time when we add a new item, and this is definitely not something that we would want to do. Instead, we can take a look at the characteristics of the Fibonacci implementation. I mentioned that it has very important properties which are common for most business calculations that we're performing, right? So first, it does not perform any side effects. This means that inside of the function, we're not sending network requests, and we're not touching local storage. We're not logging anything into the console. And it returns the exact same result when applied to the same set of arguments. So it even doesn't hold internal state, which is completely stateless. And it just receives an input and returns an output. That's it. So functions like this are called pure functions. And in Angular, we have a concept which is inspired from pure functions. These are the pure pipes. Pipes, I guess you're mostly familiar with them. They are used for just data processing. They can be either pure or impure. And the pure pipes are kind of the alternative of pure functions. They are kind of inspired from them. So they are stateless, and Angular realized that the pure functions are always going to return the exact same output when invoked with the same input. An example for a pure pipe is the date pipe, let's say. An impure pipe is the async pipe, which holds some state internally. So it can hold a reference to a promise or an observable. So it is not a pure pipe. And Angular can perform an optimization with pure pipes. It is going to invoke a pure pipe only when it detects changes inside of the pipe's input values. So again, only a reference check is going to be performed. Angular is not going to do like shallow. It's not going to compare the values with a shallow like search or with in-depth. It is just going to be a reference check. So we can take advantage of these pure pipes. We can just open Angular CLI again and generate a new pipe, ng-gp this time, and call it with the creative name calculate. So when we create the calculate pipe, this is going to add a new declaration in the employee list module. We can just go to the list component now. We can copy, just cut the Fibonacci implementation. Now we can save and move it to the pipe implementation right here. Just for completeness, we can just set the pure flag to true. By default, pipes which we declare are pure, so the default value of the flag is true. But this is just more explicit and maybe more obvious. And now we can invoke the Fibonacci implementation. And the final thing is to go to the list components template, remove the calculate invocation, and replace it with the calculate pipe. All right, well, now adding items will be faster. Maybe not noticeably faster, but we can add one log statement just to see what is going on there. So here we can log calculating with the value. We're adding a new employee, and we're calculating Fibonacci of 26. So we're not recomputing already existing values. This is because Angular treats such expressions, which are containing only pure pipes, as referentially transparent. This is a concept from functional programming, which means that if given expression performs insignificant side effect or no side effect at all, if we replace the expression with the value that it produces, the semantic or the meaning of the program will not change. So what Angular does is that when it finds that we have invoked previously Fibonacci of 27, it is just not going to invoke the expression again because we haven't changed the input of 27. We're just going to reuse the result. And the change and the semantic or the meaning of our program will not change. So this is why we can use pure pipes. Right, so it's faster now for sure. Let me take a look at the results from the bench press benchmarks. Yeah, so we're a couple of times, like a couple of hundreds of times faster again, just by using pure pipes. And that was a very simple optimization, right? Everybody can do this. Just move your pure calculations to pure pipes. But if we take a look at our data, we can see that we have basically values from small range. So here we have Fibonacci of 27 several times. We have Fibonacci of 28 and Fibonacci of 29. And Angular is going to invoke, it is going to evaluate all these pipe expressions. So if it sees that we have several employees with numeric value of 27, it is not going to reuse the value which it has already computed. It is going to recompute it every time. But on the next tick of the change detection, Angular is not going to recompute these values because they are passed to a referentially transparent expression. So with this small sample, with these values from a small sample, we can do some caching in order to speed up our application even further. Let me show you what I mean here. So here is what happens during the initial rendering of the app. You can see that we have multiple invocations of multiple logs of calculating with 29 here, and 28 and 27. So we are recomputing the same value all over again. although we know that the result of invoking calculate of 29 is going to be always the same. So if we have some global cache in terms of memoization, which is only possible for pure functions, we can speed up our application even further. And in this case, here is actually what the difference between memoization and pure pipes is going to be. So with pure pipes, as I mentioned, when Angular sees calculate of 27, it is going to compute this value. When it sees this, this expression again, calculates 27, it is going to compute the value again. And same for each next time. However, with memoization, if we have calculate of 27, we're going to compute the value, but we're also going to associate it with the arguments of the function in a cache. So we're going to associate the result of the computation with the input, which is 27. So in this cache, 27 is going to be the key, and the value is going to be the result of the computation. The next time when the same thing happens, when we have calculate of 27, we're first going to take a look at the cache. We're going to try to find whether we have 27 there. If we do have 27, we're going to reuse the result from the cache. And the same for the third calculation. So before we go to server updates, let's just do this very simple optimization. So again, here is how often the same calculation happens. We have 29 several times. And the memoization we can apply with a very simple decorator. So we can just import memo from memo decorator. And we can apply this memo decorator to our pure pipes transfer method. And that's it. We have calculated 27 only once, 28 only once, and the value from 29 only once as well. Cool. Yeah. So we haven't calculated 24 and 25, but yeah, we're just not doing any redundant calculations now. And this was only a matter of this simple decorator, which you actually have already pre-installed on your virtual machines. So memo decorator is the npm package on npm which you can reuse. And now the final part of this presentation of this session is to handle real-time updates. So for the purpose, you can first, let's reset all the changes, because we already have these saved. And switch to the server updates branch. Oh, I'll have to remove the files here. All right. So in this branch here, there is some additional piece of logic that we're going to take a look at in a second. You can also go to the server directory, and here, by using tsnode, run index.ts. All the required modules for the server on your virtual machines are already pre-installed, so you should just run tsnode index.ts. And after we refresh, we're going to see that we have very frequent real-time updates from the server, right? So this has like several issues. The most obvious one is that this is not very digestible from the user. Like, just some stuff is flickering on the screen. And the second one, we're going to take a look at it in a second, after we do a very brief performance profiling. So after performance profiling loads, we are going to see that we are actually spending a lot of time in some useless calculations which are not necessary for handling updates in such real-time manner. So we are spending about 1/4 of the time in scripting, 1/4 in rendering, and 1/4 in painting, like very roughly. And this is definitely not a good idea. So what we can do instead is to apply these real-time updates which are coming from this socket right here constantly. What we can do instead is just to apply them on chunks. So we can buffer updates for, let's say, 1 or 2 seconds. And right after that, apply all these different buffered commands, which are coming from the server, at once. And there is usually, often there is the need to run code outside of the Angular zone. This time, we don't really have to do that. So we are not going to do anything too fancy. We're just going to use some observable operators. But before that, let's take a look at the app module. So in the app module, we have one more provider now. We have the employee service. And the employee service, it is creating a new observable from the WebSocket. So we're creating a new WebSocket client. We're connecting it to a localhost port 5555. And we're after that exposing the observable through this getter. After that, we're injecting this employee service into our app component. And we're handling the updates real time in the ng-init method. So what we do is just to subscribe to the command observable and handle the commands one by one. What we can do instead is just to pipe our commands observable and invoke the buffer operator here. And to the buffer operator, we can pass observable.interval of, let's say, 200 milliseconds, 2,000 milliseconds. After we save this, we're going to see that we're getting a compile time error here. This is due to the fact that all the different commands are already buffered. So what is going to happen is that the commands observable is going to push different commands coming from the server, which are for removing or adding an item to each one of the departments. And these updates are going to be handled real time. However, when we added the buffer operator, we're just going to start buffering them until the internal observable right here, which is the interval observable, triggers a value. So each 2,000 milliseconds here, we're just going to trigger a new value. And all the buffered commands to this point are going to be pushed to the callback which we have passed to the subscribe method. And that's it. So there are an array of commands now. So let's call them commands. And let's just iterate over them. So here it is. So we are applying the updates every 2 seconds. Now, it is maybe still not the best user experience possible, but we are not at least like spamming the user with updates every 10 milliseconds. And on top of that, when we run performance benchmarks, we are definitely going to see that we have performance improvement, because at least we're performing much less frequent updates, right? So we're going to spend much less time in rendering. So yeah, of course, much less time in rendering, in scripting, and in painting. My point with this example was to show that it's not necessary to do super fancy updates, running code outside of the Angular zone, and something too Angular specific all the time. There are some concepts, such as buffering and caching, which we can apply in all different technologies, and we don't have to do like reinvent the wheel this way. So with the real-time updates, we got such performance improvement and also slight UX improvement. So that was everything that I had today. And I'm actually happy to announce that that was kind of the official release of Rime as well. So yeah, so each one of you who was able to follow along can get a virtual machine is going to get a credit for creating courses in Rime if they want to. I'll be really happy to hear your feedback about your experience. Here are some links. So I wrote a series of blog posts about these topics. There I'm going a little bit more in depth and a little bit more theory. So you might be interested to take a look at this. Thank you very much for your attention.